Okay, so we want to determine the largest loan we can afford, okay? So it's really just like before, right? In that P sub 0 is unknown, right? That's, again, let me make it bigger. Here we go. You know, just like before, P sub 0, right? Here. You know, that's the initial amount, okay? The initial amount. And that's what we're looking for. PMT is 500. You know, we're making $500 monthly payments. So you can probably guess I'm going to use the formula first, because otherwise I make this negative. R is 0.07. N is 12, because again, since we're making monthly payments, the balance is compounded, okay? As often as we're making payments. So it's monthly. T is 30 years, just like before. So this is what we get. I did check with the calculator. Again, I just plugged everything in. I mean, essentially, it's almost like before. It's just that instead of 0.05, we have 0.07. Instead of 700, we have 500. You know, I did all this in a calculator. And after all that, this is what we get. So so the biggest loan we can afford is $75,153.78. So that's what we get there, okay? That's good. Now that's part A. Now, assuming that that's the loan we take, you know, how much do we pay in total? Well, each month we're doing $500, right? We're paying $500. And this is for 30 years, 12 months a year, 30 years. That's where the 360 comes from. You multiply, take the product, and you get $180,000. Okay? Here, let me just add a comma, actually. So you get $180,000. But again, this is going to pay off this amount, but what else is it going to pay off? It's going to pay off interest. So we subtract to get this. You know, once the loan is paid off, what's the rest that we're paying off? Well, it's interest, and this is what we get as interest. Okay? This is what we get as interest. So that's how much interest we pay. I know it's a lot more than the loan amount, but, you know, again, that's going to happen. So, all right. Now, if we were to use the TVM solver, okay, let me just go through that. Let me just go through with the TVM solver. I mean, hopefully, you should be able to see that PV, again, that's the starting value of the loan. So that's unknown for us. Capital N, again, that's little n times T, which is, you know, in this case, 12 times 30, which is 360. I made it negative, right, because the money's coming away from us. You know, we're making that payment. Capital I here, that's 7, okay? You know, in this case, remember, okay, we don't move the decimal here when you use the TVM solver. We want to pay off the balance, right? So FV has to be 0. And these are both 12 as before. You know, again, you know, that's equal to little n, both of them. You know, we're compounding 12 times a year, making 12 payments per year. Okay. Okay, so just to double check that this is what we get, let's go back to that solver. Okay, so just like before, this is what we have now. Okay, so we put the data in. So we said n was 12 times 30. Okay, I think we said I was, no, 7, if I remember correctly. Let me just double check. Yes, 7. PMT is PV, we don't know. PMT, that's what we're solving for. PMT is minus 500. FV we leave as 0. Both of these are 12. So what do we do next? We're solving for PV, right? So we click that button and we get this. It looks like we get the same, or at least very close. We get $75,153.78. Exactly what we had before. What could happen also due to round-off error is if you use the formula, your answer might be off a little bit. Just letting you know. So when you're going through this with your calculator, make sure you're going to use as many decimal points as you can. It's one thing I like about using Excel because, you don't have to worry about, how do I say this? You don't have to worry about writing down the intermediate calculations. So, okay, you don't have to worry about that. Okay, so let me move on. Okay. All right. So we get the same answer, and the other parts are the same. All right, so that's really it for chapter, what was it, chapter 6, okay? Now what I want to do is move on to chapter 8. We're skipping chapter 7. So we're going to go on to chapter 8, so let me get that up. And chapter 8 is going to be fun, okay? Let me just close that. Okay. All right, so basically here, what we're going to see is the idea of probability. Basically, what's going to happen is probability. We're essentially trying to use mathematics in determining how likely something is going to happen. That's what happens with probability. Okay, we're trying to figure out how likely something is going to happen. We're coming up with a way of, how do I say this, of measuring that, so to say. Okay, so in this chapter, now we're going to see some basic concepts associated with probability. Now, I'm not sure how much set theory notation you have. There is some set theory floating around here. I'll do my best to avoid that because I didn't really cover that too much. I think they actually do that in chapter 7. But we are, however, skipping that. And then we're going to see, the idea of calculating odds. Like basically here, that just means, what are the odds in favor, the odds against. You might have heard that before, like with the lottery, for instance. We're going to see what they mean by that. And then there's this concept of expected value. We'll see that as well. I mean, you'll see what the idea there is. Well, I don't want to get into that now. It'll be too confusing. But there's really different types of probability. So you might be asking, what is it? As I said already, the whole idea of probability is we're trying to see how likely an event will occur. We're trying to apply mathematics to that. Now, the book does go into the different concepts, like with subjective, which essentially is just an educated guess, as I wrote there. You might have that, for instance, if you're wondering how likely is it that a certain baseball or basketball team will win the next game they play. But again, it's kind of hard to figure that out. It's kind of impossible to conduct that kind of experiment, because you would have to, how do I say this? You would have to have them play the same team, the same lineup on the exact, on a day almost identical to the day they're going to play, but it might be impossible to pull that off for whatever reason. What we're mostly going to focus on is theoretical. Experimental is actually when you conduct the experiment, as it's called, and you keep on, repeating it. Like flipping a coin. If you want to know how likely is it that you'll get heads if you flip a coin, well, from the experimental point of view, you just keep flipping the coin and see how many times it happens. But we're mostly going to focus on theoretical probability. Okay, that's going to be more calculation, so to say, and more, how do I say it, more, well, theoretical, I guess. And this is our definition. Here, what we're going to do is we're going to mostly deal with situations like rolling a die, a fair-sided die, that is, or tossing a coin, a fair-sided coin, where the outcomes are all equally likely. if you were to flip a coin, assuming you, how do I say it, cheat at all, and it's a regular coin, heads and tails, both of them are equally likely to, the coin is equally likely to land on heads as it is on tails. I'm not sure if the surface you flip it on will make a difference, but that doesn't come into play. Or like rolling a die, let's say, right? A six-sided die. On a die you have, on each side you have a number, or the number of dots, let's say. Well, if it's a fair die, then each side is equally likely to occur when you roll a die. You're just as equally likely to roll a 1 as you are to roll a 2. Okay, those are the kind of things we're dealing with here in theoretical probability. And this is actually our definition, as we'll see. Actually, no, here, excuse me, we see it now. Basically, if you're looking at a certain situation and you want to see how likely that is to occur, okay? Well, if there are m ways that event can occur, then the probability will be m divided by n. So if we're rolling a die, let's say, if you want to roll a certain number, there's only one way that can occur, and there are 6 possible outcomes altogether. So rolling a die and landing on 1 would be 1 out of 6, for instance. Again, I'm just starting this, so I don't want to go too into it, so to say. Okay. I mean, this is just kind of an outline. We'll see some more terminology shortly. But essentially, this is what probability is. It's the number of ways a certain event can occur divided by the total number of possible outcomes. But let me just now present the terminology. So I'm probably presenting this theoretical stuff a little too early, but here's more of the terminology stuff. You have you have this idea of an experiment, like rolling a die or picking a card out of a shuffled standard deck of 52 cards. Each possible result that can occur is called an outcome. That's what we're seeing here. Like, so for instance, again, rolling a die, right? Landing up and getting either a 1, a 2, or 3. Those are all outcomes. There's also this idea of an event, which is actually, as you'll see, it's a sub-collection of the outcomes. So it's either a particular outcome or a group of outcomes. So if you think about rolling a die, let's say, right, and getting a 1, that would be an event. Or rolling a 2, that would be an event. Or you could say, I don't know, rolling a number less than 30. That would be an event. That event has more than one outcome, but it's still an event. In fact, that event of rolling less than a 3, I think that's what I said, you could get either a 1 or a 2, right? You could break that up, in other words, into smaller outcomes. That brings this idea of simple event. A simple event is one that you cannot break down any further. So when you're looking at outcomes, let's say rolling a die, okay? Rolling a 1, well, you can't break that down any further. It's not like it's not like the event rolling a number less than 3. How can that occur? You can get a 1 or a 2. We were able to break that event down into two outcomes. That's why rolling a number less than 3 is not a simple event. It will make more sense when we do some examples. The sample space, that's just by definition all possible outcomes, okay? I don't want to get too far into this, so I think we should stop here because I might be causing a little more confusion anyway, and I don't want to do that.